Okay, ladies, I seem to not upload the video, and I have to remake this. So my apologies for it being late upload. So section 3, properties of numbers. We use these properties of numbers all the time, but we don't ever identify specifically what's going on. So the properties of equality, we probably won't be using much of these up here, but you definitely use a lot of those in geometry, okay? So these right here, we don't use very often. We do, but we don't even know it, right? Substitution property, that's something that I also sometimes use the words simplify or evaluate. Because they say simplify, or substitution, but essentially we are simplifying the numbers and or evaluating it, meaning using operations. So if we go into the additive principles here, we have the additive identity, and that's when we add 0, we get our same number. So identity means I will get my identical number again. The additive inverse means when I add that number, I get 0. Okay, so essentially like 3 minus 3 is an additive inverse, but it's 3 plus a negative 3, right? Okay, so if we go to multiplicative inverses or principles, we see that we have the identity. So when we multiply by 1, we get the same answer. The multiplicative property of 0, we know any multiplication number by 0 or multiplying by 0 will give us 0. The multiplicative inverse is when I will get 1. So if you see the additive inverse, we got 0, multiplicative inverse, we get 1, right? The additive identity is we add 0, and the multiplicative identity, we multiply by 1, okay? So a little bit different, and then we add the property of 0 because anything multiplied by 0 is 1, right? This is the only thing different that we add on that the additive principle doesn't have. So here we have basically evaluating this, right? And naming the properties for each step. So we know how to evaluate this, but we haven't ever named the steps. So that's what we're going to do. So the first thing we tend to do in here is we evaluate this, right? Okay, a lot of the times they'll say, oh yeah, that's substitution. But I tend to use simplify or evaluate. And I'm not going to make you write all of those out. One of those will work for me, okay? So then the next step would be to evaluate this, right? And look, that's 8 minus 8, and I'm going to get 0, right? And if I get 0, I know that that is the additive inverse. All right. And then the next step would be to actually multiply this out. So that's 6 plus 0. And that's, again, substitution, simplify, or evaluate. And then 6 plus 0, we know is the additive identity because I'm getting the exact same number. Excuse the ruckus in the background. Sorry for my chicken scratch. Okay? So again, we know how to evaluate these already by order of operations, but we need to know these specific properties. All right, so let's go to the next one. First thing we need to do is we need to evaluate this. So we have 5 divided by 3. So we multiplied 3 by 1 and got the same number, right? So we say that's the multiplicative, and the MULT is fine with me. That's a multiplicative identity. Oops. Okay? And now we want to simplify this on the inside, right? I don't like how this looks. I don't like how this guy looks. So I'm going to make it look like this. 5 divided by 3. And then we have 3/5 on the outside. So that is either substitution, simplify, or evaluate. Well, it's really not even evaluate there, is it? But again, substitution, simplification. Then I actually multiply them out. Well, look at that. When I multiply them out, what do I get? I multiply these out, I get 1. And if I get 1, we call that, and we know that those are inverses of each other. When we're down the line solving equations, we know that we can multiply by its inverse to get the variable by itself. So this is the multiplicative inverse. Okay, not so bad, right? So moving on. The associative and commutative properties. It only works for addition and multiplication. Commutative property is when we move the numbers around, right? Okay, so there should be a little line here. I apologize for that. There should be a line right there. So A plus B is the same as B plus A. A times B is the same thing as B times A, right? Associative is when I group things together. So when you associate yourself with somebody, you associate in that group. Okay? So we're going to be using these properties, we're going to be moving things around and then grouping them so we can solve a problem faster. So if we start off with this one here, I want to move some things around. And I want to move things around to make them nice to add. So I know this guy and this guy come together. And then this guy and this guy are easy to add. Right? And a lot of us do this in our head, but this is the commutative property. And then I group them. 23 plus 17 plus 15 plus 20. That's the associative. Oh, I didn't. Associative. It's kind of crazy that ASS is standing out to me. And yes, it's the associative property of equality. And in geometry, you'll use that equality. And then our last step would be to actually evaluate these, right? Use substitution or evaluate. So I know 23 plus 17 is 40. And 15 plus 20 is 35. And that's substitution, simplify, or evaluate. And then I'll actually add those together, which is 75. So substitution, simplify, evaluate. Okay. We'll do one last one here with multiplication. Okay. Group things together, or we'll move them around first. I think it really actually doesn't matter the way you move it around. Sometimes it's easier one way than the other. I want to say these two together first, and then these two. You could have thought of it differently. Then I grouped them. Oh, I didn't put my reasoning. That was the commutative property. And then I group them. So that's associative. Okay. And then I actually evaluate. Ooh, I don't like green and red because it reminds me of Christmas. I like Christmas, but just not when it's not Christmas. 4 times 80. And I think that's easy because and so that's substitution, simplify, or evaluate. And then this would be, the 4 times 8 is 32, and then add the 0. So substitution, simplify, evaluate. All right. So now the next stuff we do is pretty simple. It's the distributive property, and we've all used this already before. So when we do distributive property, we multiply everything on the outside to the inside. So 5 times 3g is 15g, and then 5 times 9 is 45, or negative 9, right? And that's it. Even if the variable is on the outside here, it still multiplies inside. So we have 8 times z squared plus 24z minus 32. So again, multiplying the 8 into all of those. All right. Sometimes there will be like terms that you need to combine. So let's first distribute. And we'll just drop that 4x and we'll distribute. And these are like terms, right? So 4x plus 24x is 28x minus 18. And this 18 is not a like term because it doesn't have an x. All right, so let's try this one. The negative 3 needs to be distributed. So we do 6s squared. Negative 3 times positive 5 is negative 15s. Well, the s. And then negative 3 times negative s is positive 3s, right? So when you distribute a negative, those signs change inside. So what are the like terms here? These are like terms, okay? This is not a like term because it has a square, right? So we add these together. We keep the 6s squared just there. And we have negative 15 plus 3. And we know that that's negative 12s. Okay? Last one here. No distributing, but combining like terms. And I'm going to put it in something called standard form. Which means I am going to have, decreasing exponent order. So I know that my a squared should go first. And then I have my a's. So I have 5a minus 21a, and that's negative 16a. And then to tag along on the end there, we have that constant of a negative 2. Okay, that is it, ladies. And I believe in the homework, I did not want you to do a certain problem. Maybe it was number 10 I didn't want you to do. Maybe that's, I'm mixing all my days together, and I apologize. Have a good